delighted that Charles could join us again. It's not his first rodeo with a DPIRD, but I think he's probably finding that that the engagement of the department and the sort of interaction is probably different from the original times, the first few times that he's come across DPIRD. Also want to acknowledge in the audience Dr Simon Carroll, who's Emeritus Science lead from the WA Museum and has been working as a partner with the WA Climate Resilience Task Force as part of a relationship that we've had between DPIRD and WA Museum at large, to reach out to a sort of non-traditional audience, if you like, the audience of the museum, to talk to people about agriculture, to talk to people about the landscape, biodiversity and the environment. So we've had a range of events that have happened during the year that staff in the museum have been involved in, not just with Bullabada, which is then there's a presentation tonight that Charles is giving, but also in our regional museum network. And I guess can I urge our staff online to think about the museums as being a place of gathering in our regional centres that we can use and access. And also great that Grower Group Alliance, our partner in DPIRD, and Callista's joined us in person. All right, I'll throw to Charles, and then who's got a presentation you'd like to make, then we'll take questions both online and in person, but that'll be later. We've got a bit of time, so over to you, Charles.
Thank you very much, and thanks for the opportunity to share ideas, because that's really what this is about. I think there's some really exciting stuff happening, and I'd like to gallop broadly across a big landscape. And it's not either or stuff. I think there's a transition in process, which I will discuss, which has to be done gently and at its own speed by farming innovators integrating with scientists and others. So I think it's a particularly exciting development what's happening, and to see, we just had a terrific meeting next door. There's so much passion and insight, and that's what the process has to be, because there is division, there's threats with challenge paradigms, and as you'll see, I think the issues confronting us to do with climate and Anthropocene issues about our planet. This is an exciting space to be in. So what I like to do then is quickly skate through just some ideas by PowerPoint, which is a lot better than looking my ugly face. And that hopefully will open it up for discussion at the end. I am really concerned about the planetary challenges facing us and the human health crisis. And because I'm associated with friends who are some of the leaders in this space and who interact with the Stockholm Resilience Institute, Will Steffen, John Finnegan and others at ANU and CSIRO. So that's my focus. How do we regenerate planetary, farm and human health? And this story is one of the pathways. So what I'm really talking about, because I had to lecture master's students and third years a little while ago, and having been away from uni for that 80s and 90s decades, the whole rise of the computer era, which led to our understanding of complex adaptive systems. What we're talking about even with landscapes is they are complex adaptive systems, and it's how we enhance that complex functioning. You won't be able to see the detail. I thought I'd start here, a sort of spiral view of the evolution of Earth and life. You know, obviously at the centre, our planet formed about 4.6 billion years ago. First life emerged around about 3.8 billion years ago, but relevance to us, mammals didn't come along until about 400 million years ago. And then if you think about our first grasslands, grassy woodlands, the C3 grasslands, that was about 25 million years ago, and the C4 grasslands about 50 million years ago. The summer active, improved carbon functioning. That means that's a fair period for grasslands and ruminants to co-evolve together in that 25 million period of time, with soil biology and all those grasslands grazed by ruminants that we're talking about relative to Western agriculture and us. And that includes the modern cereals were part of those grasslands, and they're adapted to being grazed by ruminants. Even saliva will stimulate, animal saliva will stimulate certain propagation. That's how they co-evolve so closely. So as those rats are discovering, we're getting in an uncomfortable position regarding our planet and its systems. As far as we know, this is the only blue-green planet in the entire universe, planet that's evolved due to life and its protective mechanisms due to that evolution of life. It's got an extraordinary situation. I don't think when I mentioned the Anthropocene that's coming as any surprise now. That's not far from home. Big fire events getting far more frequently due to what we're doing to climate and landscapes desiccating quicker. Recent flood events up the north coast, Brisbane, they're off the chart in terms of frequency now. As I say, it's the greatest crisis we've ever confronted, this Anthropocene issue. And what's behind it, and I'm sure you're all familiar with it, post the 1950s takeoff of the world economy after the Second World War. The orange are all the socio-economic trends. Doesn't matter if it's population, real GDP, use of energy, use of water. It's all the same exponential takeoff. On the blue side, the Earth system trends are the same, whether it's all the atmospheric gases, surface temperature, the way we're consuming fish, the way we're overusing water and all those sorts of things. So the net results, given that we've got a planet that's sustained in the most hostile environment imaginable by these 9 Earth systems, climate, the ocean, stratospheric ozone layer, the integrated nitrogen phosphorus cycle, fresh water, land use and biodiversity, etc. That's what sustains us within a thin membrane in this hostile planet. So what we're now finding, there's a lot of evidence to show that, hence the blue crosses, that 6 of those 9 biogeophysical systems that sustain our planet are forms of modern agriculture. If they're not a major player, they're a key player in the destabilisation of those systems. I think the excess release of carbon to the atmosphere is obvious. That's absorbed in the ocean, leads to increased acidification of the oceans and threatening of some of the marine systems. Through the use of excess nitrogen in agriculture, that's destabilising that system. As a species, we're using far too much fresh water, degrading a lot of land, and then you've got the big one on the bottom left there, the biodiversity loss. There's been 5 major extinction events, as I'm sure you all know, in the history of our planet. The last one was about 62 million years ago when an asteroid hit, wiping out well over 90% of all life on Earth. Our species has now triggered the 6th greatest extinction event in the history of our planet. So that's a bad story. I think there is grounds for hope, and I guess I've been on road trips and through my book and other speaking. I think that regenerative agriculture, whatever you want to call it, sustainable agriculture, but I prefer the term regen. It provides some very, very good, if not some of the best solutions to addressing some of these planetary issues. So how did we get into our mess? Well, our Western agriculture began on the eastern end of the Mediterranean, in the Middle East. As soon as our Earth moved into that stable Holocene period, the ideal temperature and climatic situation that allowed humans to thrive and agriculture to evolve with it. As you know, our Western agriculture evolved in that eastern end of the Mediterranean, Turkey, Iran, Iraq, beautiful grasslands. Most of the Mediterranean was forested at that time. Great river systems, and within those grasslands were these little annual weedy plants that we call the modern cereals, etc., as I mentioned. That is the fertile crescent today. Through constant corrosion of those grasslands, most of the big rivers became saline. And you go around the top of Africa and the Sahel as well. It's a constant drought, pretty much, and hence constant social conflict. We're still good at creating deserts through the way we treat our land. Obviously, the Dust Bowls. President Roosevelt, signing the state conservation law, said that a nation that destroys its soils destroys itself. And globally, the UNFAO figures will show that we're pushing towards degrading upwards of nearly 40% of all land suitable for agriculture, something we can't afford as our population is going north at an exponential rate. And the minute we start through whatever methods, and I'll show you, I was good at one of them, overgrazing. As soon as we start that process of releasing carbon dioxide, carbon into the air, we're on the path towards desertification. As simple as that. We've had our own dust bowls in Australia. We don't talk about them. A fair amount of soil went west with some of that mallee drought, but it was wider than that. It was way out the Western Division of New South Wales into South Australia. Wes Jackson, who's the leading agrarian thinker in the States, I think makes a very cogent point that the ploughshare may well have destroyed more options for future generations than the sword. And it's not in the past. It's only a couple of years ago at home, and there's a few more. Other than that, I remember as a young mountaineer climbing on red ice in New Zealand, and it turned red again in the last few years. Millions of tonnes of our precious topsoil have gone east. But as I say, there is another pathway. That's what I now like to sort of cover. So I guess it sounds simplistic, but if we get healthy landscapes and soils, and that's functioning landscapes, from that comes healthy food and fibre, and healthy profits, people and a healthy planet. You know, sounds good news stuff, but I really do believe it, and would like to show what I'm talking about. So I come back to a sort of different definition of regenerative agriculture, that it's agricultural practices that allow landscapes and systems to self-organise back to health. They're long co-evolved. We put the lid on them going back to the way they've co-evolved to work. And if we can operate with some of the regenerative systems, they will self-heal, and in thinking of complex adaptive systems, they will use the emergent properties that still reside within to do that regeneration. So, having learnt the hard way, I came about understanding how to manage landscapes to a healthy function by gaining ecological literacy, which I didn't have when I started at the age of 22 when I had to take over the farm. Because what's happening with much of the power behind aspects of modern agriculture is we don't get taught a wider, more complex view of agriculture. This was a full page, A3 page ad in the major rural weeklies in Australia about 6 years ago for Roundup. White pointer aggressing, attacking soil, a sexy face on the Roundup drum, fine print, trust your killer instincts embedded within. So that's the sort of message we're getting, and it's what leads to landscape illiteracy, because you see the earth that we work with as an inanimate substrate rather than a complex self-organising system. So I started at 22, had a merino stud that I thought was important, built on molecular genetics and stuff, and I thought that was my major asset. We walked into a 5-year drought. I defended that asset, and that's what I did to my land. I still grieve over it. So I'm an expert at making mistakes. And that was because I wasn't ecologically literate. I didn't understand how that landscape, that complex adaptive system worked. The good news is that the best things in life are free, as Brer Rabbit will testify. And I'm talking about sunlight and photosynthesis and carbon going in the ground. We get that for free, and we just got to use it. So Alan Savory, the African Zimbabwean who developed the holistic grazing approach that's now widely adopted worldwide with tens of millions of hectares in every continent going into it, he had 1 to 4 of the key sort of systems in teaching ecological literacy. So clearly, solar energy puts sugar in the soil, drives soil biology and the water cycle, because without carbon, you're not going to hold much water. And that impacts biodiversity. And then I've added the 5th component, that weird species there, we humans. The important point, if you get this working, is the total interconnectivity between all 5 with those arrows every which way. And that's a feedback process. And it also undergirds our entire landscapes and human civilization. Just think fossil fuel that we now depend on as from that. But if we do some of this sort of stuff, interfering with that carbon pathway and releasing it, those interconnectivity every which way start to get interfered with, and the system stops working. So what I'd quickly like to do is just give you some illustrations of sort of farmers that are working in this regenerative space that are maximising those 5 landscape functions. So as a landscape manager myself, I see my role in crude terms as stacking on as many solar panels as I can on my landscape for as long as I can throughout the year, and protecting what they put in the soil, that valuable carbon and sugars, for as long as I can. It's a fairly simple approach in preventing degradation and loss of carbon again. Alan Savory, biologist in the 60s, in what is now Zimbabwe, asked the question, how come you can have millions of animals in mass herds and you've got the healthiest grasslands imaginable? I mean, North America also had anywhere from 50 to 70 million buffalo pre-European invasion. And in both cases, these mass herds with dung and urine and intense animal impact were only ever there a few days because they had the big cat predators constantly driving them. And then they wouldn't come back from their migratory path for up to 6 months or more. So what Savory eventually came up with was pretty much 3 simple principles: mass, animal intensity, dung and urine, very brief grazing periods, 1 to 2, 3 days max, and then a long rest period before they came back. And that's really what the whole worldwide system on regenerative grazing, with a lot of sophistication added in now, but it's as simple as that. That's what it's built on, because that's what seems to develop the grasslands and the soils to maximum. And when it's well administered, this actually was a photo from Tim Wiley, one of the then Department of Ag, WA, way up in the Pilbara. This property, I suspect that area was settled about 1870, 1880. So over 100 years of what was really set stocking. The animals never left the soil. So you're ending up with country, by the end of that process, with well less than 10% ground cover. But within 11 years, these photos taken at the same time, just next door, you end up with that sort of process, well in excess of 90% ground cover now, and an increased productivity, in this case, 2 or 3-fold. I mean, that's extreme degradation. Another quick example in northwest Queensland, west of Bowen. By the way, that tree with the red arrow is the same marker in that landscape. 100 years of overgrazing and two regular burning events, a set stock, high compaction, simplification of an ecosystem. And within 10 years, you can see the regen starting to come, and again, production lifted. What's now emerging in this space is same principles in cropping, because if you going back to the point I made, that we know in the grasslands where modern cereals and that were domesticated, they were part of a grazing landscape, that they're adapted to being grazed by rumen, stimulation by saliva and all that sort of stuff, and the way teeth will cut. So what the modern cropping evolution, multi-species cover cropping, pasture cropping, etc., is working on is replicating the diversity of a grassland, trying to use, if they can, elements of the 5 plant genera, but minimum for 14 to 25, 30 different species, and then grazed. And if it's grazed strategically, you can still harvest the cereal, and then you've got your summer feed and ground cover going through, and the biology continues to be sustained and protected. Do we get all that right? It impacts the water cycle, because carbon in the ground directly relates to how much water can be stored. So this is an example of one of the early Savory clients in northwest Mexico, which probably had a couple of 100 years at least of overgrazing, set stocking. That blue arrow is the same point in that landscape, just 27 years apart. So, that sort of past history, compacted grounds, no diversity, you get a big rain event, ends up the bottom. Turn that around after 27 years and no visible water, but 10,000 times more in ground and a huge regeneration. Basically, what it's doing is enabling self-organisation of those ancient systems to get working. And you get these marvellous responses. And another spin on that, this is an example of country I know very well. It's at home. Recent drought, which broke July 2020. So I went to drive the month before. There's a neighbour that didn't like grass. Basically, just said stopped until they started to die and had to be cleaned off fences and stuff. This person over the road matched their grazing to their rainfall and stock numbers and sold down, then adjusted and eventually got 90% of stock off the place to keep the cover. So months later, we get 100 millimetres of rain. I went for a drive at the 10 mil mark, and this country here was already sheeting brown water. The place over the road, you couldn't see any visible water, it had all gone in. 24 hours later, when the rain stopped, I went for a drive. This was just a mud bath. The dams were full of mud and shit and stuff. Still no visible water next door. It had all gone in. So you think about that by keeping your soil structure and your carbon, your biology. This place here fixed pretty much 100% of that rain event, and the neighbour across the road only fixed about 15%. In a continent that's our major limiting factor. I won't go into the details here. You've probably seen this photo of the, I think it's the 10-inch isohype level west of the Nullarbor, where they built the bunny fence and started to clear the Mallee after the Second World War. The recent evidence is showing that the rainfall in this allegedly once drier area is higher now than a kilometre or so into the what was once the higher rainfall area, and you can see the cloud formation over it. Just pointing out the fact that it's rain-making bacteria that originate from our plants on the land. And the small water cycle is really built around plant microbes that act as a nuclei around which water droplets and the ice crystals can form. So cloud-making bacteria can contain proteins that do contain proteins that allow the ice formation. Because one bacteria can be the source. It's a lot of recent evidence here. I haven't quoted it. One bacteria can be the source of 1,000 ice crystals, and they've now found that both in the States and elsewhere, the cloud water can contain up to 28,000 different species of bacteria to help that rainfall formation. So keeping the ground cover, especially if it's active growth, is just fundamental. And I've put a shovel in, as I'm sure some of the agronomists maybe watching have done in different places around Australia, and you strike different levels of compaction depending on what the technology was, with original moldboard ploughs up to some of the modern devices, and you'll find different layers of compaction from our tillage history. In no-till fields, or really well-managed fields, you can see when roots in modern systems, some of the modern compacted systems hit those compacted layers, they go naturally. In a really healthy tilth, they keep going down, accessing more nutrients, and that's highly correlated to water penetration. I think some of you might have seen this before. I took this when I was cutting across the head of the Liverpool Plains, sort of soil that would make Western Australians kill for. It's beautiful dark chocolate volcanic soils. In dry season, the night before they had just 8 mils of rain. I came through in the morning and saw this and stopped, went for a walk. And those soils were so dead, so capped, and so lifeless from the overworking, etc., etc., and the chemicals that they could not absorb 8 mils. I was quite shocked. So I guess what I'm saying, we can't go back, but through some of the new cropping and grazing, we can start restoring the full potential of a small water cycle and restore those 5 landscape functions, because they're all the 4 biogeophysical ones, they're all fully related. Something I didn't appreciate, I mean, this is really the guts of a living soil biology, which is what I was totally ignorant of. I might have looked at a worm, but I didn't realise 90% of it is invisible. So we know, and this is 101 for you guys, but about 93% of non-plant organisms are microbes, and because we can't see them, I never reacted to it. And you know, they feed on the exudates of green plants, and so on. The whole system powers away. So quite simply, an aggregated healthy soil full of biology, it's a community. It is not a commodity. And you've probably heard of these guys plenty of times, so I'll skip through what's been an extraordinary innovation step, which is really the replacement of traditional inputs with biology. So, and in some of your tough Western Australian soils, they now have a very resilient, viable system. We're at the point of planting their cereals, for example. They have one injector putting worm juice, the biology around the seed, and another injector putting compost extract, the food for the biology around at the same time. And so it's led to a transformation, keeping the ground covered as well. So 40 metres, this was done a few years ago, microscopy by West Australian, pretty much standard post-harvest. I remember visiting round plants over here, November, a bit later, a reasonable amount of bare ground. And when you have that sort of system, you go put a shovel in about that far down. There's not much biology visible. In this case, same day, 40 metres across, shovel went in and you couldn't see the roots because of the biological aggregation and even sticky lines of vermilion and those long-lasting carbons. And the Haggerty's then ended up with ground cover for the summer and sheep feed, depending on the season, whether it was green or dried off. Walter Yaner, ex-CSIRO soil scientist, has that wonderful metaphor: our soil should be like cathedrals. There's a hell of a lot goes on. You know, a really healthy aggregated soil should be 50% air, about at least. And that's where water is stored. You get nutrient exchange, protection from disease, and critical cations are attached on those big spaces, and so on. And really, sum it up, healthy soil has intelligent, selective interfaces. And I think intuitively, that's why the Haggerty's call their process natural intelligence farming. But if we go on bearing the soil, killing the biology, no difference to those soil cathedrals, what happened in the Second World War when they were bombed into dysfunctionality. So really what's happening now, and with multi-species cover cropping, is trying to replicate how nature works. Back in the way it once worked, multi-species covers, etc. And you're working again with how nature's co-evolved. I won't go on. Gabe Brown is one of the pioneers in the States, worked with Australians, both soil biologists and farmers. He's totally transformed his system using the animals, high density animals, to lay down his cover to put his spring plantings in. I know it's different here because they're coming off probably snow that melts in the spring, so it's an ideal situation compared to what we have to contend with. But when Christine Jones was there, she persuaded Gabe to hop over the fence and take out a shovel full of his traditional neighbour's soil, where he'd been 10 years ago. That's it on the top. And Gabe's is now on the bottom. It's 10 years after, 12 years. You can see earthworms and the aggregation. And at the time, we've done some measurements. And we're talking about beautiful journalism type soils in that northern prairies. First inch taking 9 seconds to penetrate, second one 16, but that clod taking up to a couple of hours for an inch to disappear. And I think if you had a penetrometer, Gabe's probably be a couple of hundred PSI, but that clod would be, if you didn't break the penetrometer, it'd be about 1,000. I'm not going to go into this, but I'm sure the microbiologists will be aware, and it's really creating excitement amongst soil biologists and some of the leading farmers, that if you get all those things right, you get this extraordinary development that the microbiologists have known about and we're just learning about. I'm sure DPIRD's probably across it too, what's called quorum sensing, where you start to get communication, a minimum quorum sensing communication, which is using hormones and other chemicals, where you start to get this incredible interaction between plants and the microbes. So, for example, a microbe's running out of nitrogen, it releases a specific hormone or chemical. The bacteria pick it up and they'll migrate over and form nodules and start fixing nitrogen. And same with disease protection. It's quite an extraordinary development. I don't know whether the department here is working on it, but it's certainly gaining recognition. And one of the leaders in the States, Professor David Johnson, has found that the quorum sensing signal proteins, which are the regulation messengers, about 10 times higher in healthy soils than stress ones. And they're triggering the housekeeping gene expressions. Drought resistance, plant growth, regulation, nutrient increases, big increases in soil carbon use, efficiency and disease protection. Pretty good package of factors. But then nature's been working on it for millions of years, and we just got to enable her. And so the fourth of those biogeophysical systems, biodiversity, which I needn't hammer here. I think you guys, some of the leaders in getting that back into farming systems, pest control, insect control, etc., etc. I put a native bee in. Thank you. Simon picked me up because I'd forgotten, focusing on a European bee, that we've got an extraordinary diversity of native bees that also do a lot of pollinating. But the point I've got that up for, you can see that beautiful photo with its pollen, is the evidence in the last 2 years that's come out of northern Germany that compared to 40 years ago of their test sites in forest country, not farming country. They went back 2 years ago after 40 years and insect numbers have crashed 70%. It's really ringing alarm bells around the world. And of course, diversity in farming systems, you all know better than I do, Cagassassi, tree lucerne and other edible shrubs, putting in a vertical layer, not just horizontal, can have huge impact in grazing and rangeland systems. So how does this relate to the Anthropocene that we discussed back there, which is something that really concerns me and a lot of our scientists in this space? Just a reminder of those destabilised systems of which our modern agriculture is a key player in the Blue Cross areas. Had the privilege of working with Paul Hawken a bit, and he commissioned 70 scientists a few years ago. It went into 23 different languages, this Penguin book, a huge publication. They looked at the 100 best methods to pull down carbon and put it away. And when he went through it, he realised that out of the top 24 best methods, about 12 of them were variants of, if you want to call it, regenerative. So put them all together and call them regenerative or sustainable ag, whatever your terminology, it end up being probably the very best way to pull down carbon dioxide from the atmosphere. I would have thought that's a pretty exciting message. And of course, once you address that carbon aspect, that climate aspect, more soil carbon impact in turn impacts 5 of the other 9 systems, Earth systems that I was talking about. And now recently, US government last year commissioned Princeton University to do their definitive towards net zero plan. And one of their conclusions early on in the report, most cropland topsoils, we're talking about the states obviously here, now contain less than 60% of their original carbon stocks. Estimated that worldwide agricultural practices have resulted in the loss of about 130 billion tonnes of carbon. You then dig around in the 5th part of the report, they make the statement that regenerative agricultural management practices have the capacity to rebuild much of these carbon stocks, which is pretty much what I've been saying, but now starting to be recognised by leading soil scientists. And finally, before I put you all to sleep, all this also relates to the human health crisis because it's the biology that's really accessing critical nutrients, which we've co-evolved for our health over a long period and our animals' health. And that great acceleration process I spoke about that relates to the planet, delayed by a couple of decades from the if you think about the big chemical revolution from the 1950s on, 2 decades and a bit more later, we're starting to see these same exponential curves for the modern health diseases. The ADHDs, the obesities, the cancers, and the red lines have been superimposed is also correlated with the use of glyphosate. Roundup. I know sort of hard to prove direct causal relationships, but I think the 2 exponential graphs are more than worth pondering. And there's heaps of research, you guys know better than I do, that's showing that compared to, say, the Federation, the tall Federation wheats, etc., that the move towards high production and dwarf wheats and all that sort of stuff, wonderful increases in yield, but a lot of research, Britain, America, and Europe, that shows a major crash in the high yield input responsive cultivars of micronutrient deficiencies, copper, iron, magnesium, manganese, etc., etc. So there's always a penalty when you push maximum production. I found that with resilience in sheep breeding. So I'm summarising a lot of stuff here, but causes of decline in nutrients, obviously what the big food manufacturers are doing to our modern foods, including the GM process of interfering with long co-evolved complex genomics. We've got to be careful of that. I've learnt the hard way talking to molecular geneticists. Killing off our soil biology through various methods. In other words, most of the decline in nutrients is related to a serious decline in soil health. That's the critical one, that the soil biology, or lack of it, is just not putting it back into our foods. And I'm just summarising the work of Professor Don Huber and others that are working in the space with glyphosate. They paid the penalty for it by taking on the establishments. But they sort of sum up the 4 things that really concern them about glyphosate. That it's a chelator. So if you think about when it gets into the human gut or the animal gut, it's going to aggregate out of solution important minerals, etc. Interferes in the vital microbial Shikimati pathway, which is a pathway in the gut microbes right at the end of the process of protein formation. It's cut and interferes right at the end. We know glyphosate is water soluble and it's now being found to penetrate key body barriers, blood, even the blood-brain, and recent evidence on the placental barrier. And a number of the scientists like Dr. Zach Bush, who specialises in autism in the States with a big clinic now, they think one of the big effects in the gut microbiome is epigenetic, switching on and off of the wrong genes for a purpose. Bob Kramer used to work for the USDA, but he's challenging the establishment. Many didn't stay there long. And Professor Don Huber has actually survived a hit on his life for speaking out over many decades, and he can do a 2-day talk just on his concerns. They'll go through a huge range of concerns about what glyphosate is doing. Some of Huber's concerns, about glyphosate, nutrient deficiency, increased levels of toxic products for animals and humans, and so on. I think this was alluded to earlier. A Canadian analyst, I was sent this out of Canada. He looked at the share of the cake in modern cropping in the Canadian prairies, and he found if you realise net farm income, taking out the taxpayer support, which they get a fair bit of, that's the green segment, net farm income. The blue is the share that goes to the big boys. What was then the Monsantos, the Agriums, the Deeres, the Shells, all the big suppliers. And we find out about a 1.35 trillion cake between 1985 and 2016, so in 30 years, 1.35 trillion. The big end of town gets 93%, 1.32 trillion farmers get the drips. So, you know, who's having who on? And making maybe an extreme statement, but really that sort of agriculture came out of the giant stockpiles left over the Second World War, and a lot of the big companies said, how can we then turn this into profit? And so, but what we're now finding with the new regenerative cropping practices is they can farm successfully without glyphosate. Doesn't matter if it's natural intelligence agriculture, pasture cropping, and the multi-species variety. They're using animals in the system to do a lot of the control and keep the ground covered. And so all this is relating to addressing human ill health. And just without getting into all that, I mean, I think it's obvious by returning to the systems that we're naturally co-evolved for, with the nutrients coming through our food naturally. So that's why it's, I think intuitively what is behind a lot of the modern urban food movement, et cetera, and traditional cultures, both consumers and farmers, trying to get back to what we co-evolved for. Our children now are certainly spending far too much time on the devices. They're not getting out into nature. You know, babies, toddlers need to crawl around in the dirt, ingest some dirt to develop a robust microbiome. That's not happening. You're getting all sorts of modern diseases as a result. I think you nearly heard enough of me, so I'm going to wrap up very quickly. Paul Hawkins says, and he's now joined by leading Australian and worldwide scientists about the Anthropocene. They believe we've really only got one generation to turn all this around, or we could get runaway planetary events. Donald Worcester, an excellent environmental historian in the States, I think has 3 very good principles for good farming: making people healthier, promoting a just society, and preserving the earth in this network of life. So look, I think I'll leave it there and throw it open if there's any questions.
So a lot of thank yous for a very interesting and informative discussion. And I think one of the things that I think we all appreciate in an organisation like ours, which is big and diverse and has lots of capacity and lots of people from different backgrounds, it's the idea to be stimulated, to be challenged, and then to think of ideas. And I think that's and the contest of ideas is what we're about, because we're all here to make a difference for agriculture, landscapes, and regional and rural communities. So, question from Simon Merriweather online. What's your expectation/hope of government's role from education, inducements, incentive, and/or compliance? And I guess that's a similar issue to what Nathan mentioned earlier, and the carrot or the stick, or what combination, or what things, I guess, from your perspective, you've seen that works or could work.
All right, I can get into a lot of trouble.
This is we're here for ideas.
Yeah, no, look, I'm not going to be destructive. I think you guys are lucky. You have a minister that's really on side and courageous. A previous book I wrote was titled. It was about breaking the sheep's back. It was called. It was the political destruction of the wool industry, mainly through conservative politics and agri-politics, which was a $20 billion disaster that destroyed permanently half our wool capacity. So I have little faith in the political process as the driver. I think it's farmers and scientists that are going to be the innovators, and if government can support us, that's great, but it's not the only way around.
All right, thank you. Mark Chmielewski, and just do a quick introduction so that Simon and Charles get an idea of the diversity of people in the room.
Thanks, Charles. Mark Chmielewski, Aboriginal Economic Development. We have a program working with Aboriginal farmers all across the state. I'm just reflecting on your opening statement about farmers managed landscapes, which is very similar to the mantra that a lot of Aboriginal people that we work with about managing country.
Yeah.
And there's a lot of parallels there. And I guess from your perspective, you know, what parallels do you draw from traditional ecological knowledge in designing a future for agriculture?
That's a great question. I'm privileged to work with a senior lawman and Ngarigo man at home, and he certainly influenced me. I've learned on this journey, moving, if you like, from a mechanistic mind where my inputs were everything and, aggressive ploughing and all that, and the stock were just an entity to make profit out of. It was becoming more empathic and far more observant about what my land was doing. And that's really the crux. Once you get into, for example, ecological grazing, you just have to read the landscape constantly. And we've planted 70 to 80,000 mixed tree breaks now to get some functionality back into our overcleared granite, and then you're learning principles out of some of the leading biodiversity guys, say at ANU, with minimum widths of tree breaks for viability and stuff, and then you start to observe the impact of that natural function in your spiders and your other predatory insects and birds, and I started off as a bird watcher as a youth, and then I left all that behind when I got focused on the dollar and trying to preserve a family farm. But I've come back to that engagement with landscape, and that's what, at least I think, both ecological grazing and the integrated cropping now requires of us. We've really got to be in tune with our landscape and react accordingly, and become more empathic with country, as you say, and I think it's a nice convergence.
Couple of interesting questions online, then I'll come back to. So how does, from Stefania, how does harvest work in a silvo pastoral system? Would it mean for farmers to change their equipment and practices? Is it economically viable?
I can't speak. I know there's a lot of good stuff being done on the west with Takasaki and etc. But in some of our country, where we are, just for example, as my example, degraded country that needs stabilisation, you put in edible shrubs, and we did a trial with some of the guys at Sadi that had a national shrub trial testing scheme going. They looked at 100 species. I think it has a role in reclaiming country, but to put too much of it into cropping, because what you want is perennial shrubs, not just ephemeral shrubs. You want them to go down and start bringing nutrients. And one of the things I noticed of mixed wattle plantings was the animal wisdom of our ruminants that have co-evolved in nature. They can still, work of Professor Fred Provenza at Utah State Uni will show, they have an extraordinary capacity to detect phytochemicals in plants. And so I noticed every time I was moving sheep or cattle through these grazing shrubs, they would target certain wattles for the tannin, the self-medication, for example. And so, instead of treating them like almost a factory animal, I think you've got to respect that. And that's where you can have shrubs for medicine and protein. And we found Tagasassi at home. For example, we've got 4 inches of snow on the ground at home at the moment, and it's still snowing, and we can get down to -12. So we don't get much growth in the winter, and it's hard to get flowering shrubs. But the Tagasassi will flower much of the winter. So we've now got that missing hole for flowers for birds and insects, etc. So it's a bit of a ramble, but I think shrubs, that vertical layer, depending on your land, is critical, certainly in our situation.
Thanks. Dr. Amirabadi.
Hi, I'm Amirabadi from the economics section of DPIRD. Thank you for your contribution. I enjoyed it thoroughly. In my previous work, I looked at Tagasassi and the economics of it in the very sandy belt regions, region north of Perth, Badgingarra, places like that, and we did it for rural industries in the local corporation, and it showed the circumstances under which it could be profitable, and I'd love to see that continue. So I'm glad to hear you speak about shrubs and their role in grazing management. One thing that we economists constantly find difficult to communicate with growers and with policymakers is the transition from a current state, equilibrium A, which could be either stable or degenerating, versus or improving ever so slightly to a more regenerative system, And I wondered if you have got good examples, good case studies of these where the transition happens. And I've read your own case in the Reed Warbler book where you transitioned, but you had to make some capital adjustments and things like that. Could you speak to that?
Oh, it's a great question. I think that the lesson is, you know, I made the mistake with enthusiasm, you evangelists jumping in too fast. You know, we used to use superphosphates. Some of our like granites at home need a bit of that. And when we went cold turkey, there was definitely a depression in production in the pastures. Reading our grazing charts and performance. Taking it small steps and allowing change to occur rather than rushing it was my lesson out of all that. Don't try and do everything at once because of the evangelistic feeling. You know, stage manage it through to allow, and within about 5 years, as soil biology got going, we noticed as much as you can in variable seasons, but the production seemed to come up back to where it was, or if not better. And it's certainly better once we got the grazing right.
That certainly reflects the experience that Brendan Savage has had at Cool, that's what's been picked up out of the case study there. Ben, you had a question?
Hi, Charles. Great to see you in person this time. Ben Bidoff, Chief Scientist across Primary Industries.
Yeah.
My question is more around, like, with all of our production systems, regardless of whether they're industrial or regenerative, our biggest challenge with our growing population is particularly, and that's more relevant Western Australia because we export all of our produce. So we export all of our produce to Southeast Asia. 90% of it goes out. With that goes all of that micronutrition, which, you know, is deficient in a lot of our newer foods. Our soil's already deficient in, you know, everything pretty much,
yep.
As you know. How do we address that globally? Because essentially, you know, we aren't importing biosolids from where we export our current produce to. How do we actually close that loop? That's one of the biggest challenges for all of our production systems, regardless of what approach you take going forward. And I guess, do you have any perspective on that in terms of regenerative agricultural perception on where that's going into the future?
Wow, that's a hell of a question. Because obviously the balance is we've got to feed the world, which is, you know, accelerating. But, you know, some of the analogy that's coming out of the States, those nutrient deficient foods and some of the stuff that's in them, the costs in human health and the loading that's going to put on, especially modern economies, that's the conundrum. You know, it's almost sort of a classic compromise choice. I mean, we do forget in the Western world, and it's not deriding what you're saying at all, but the FAO about 4 years ago came out with the astounding stats that 70% of the world's food comes off peasant farms, about 6 acres and less. So we're not the dominant force in food production, but that's your classic compromise decision making, isn't it? Yeah, I'm certainly not saying turn off the tap on the modern fertilisers if you want farmers to remain viable, but the costs are going to be both environmental and human issues down the track. So I don't know how we're going to come out of that. We've become a plague species. There's too many of us and we're breeding too fast. So it's one of those classic conundrums.
I think that sounds like a good research project as part of the climate program to model that, Ben. There's lots of questions online, but I am mindful that you said 11 o'clock. But are you happy to take a couple more questions?
Sure, if they're not all asleep.
And acknowledging that if people need to leave, certainly both online and in person, certainly thank you for coming. And just before I ask the next question, can I also acknowledge we run these series of workshops and we've had this visit. I'll just acknowledge the work that Jane does in pulling all these things together for us. Both on a there's lots of effort goes into this stuff, and also working with in bringing Charles on. But I just want to acknowledge the opportunity to have these discussions and have these stimulating ideas is very much thanks to Jane's efforts. So an interesting question from Grant. Yes, so I think it's based at our Meriden office. Regen approach seems to heavy reliance on livestock such as sheep, with decline of sheep numbers in WA, especially in the eastern wheat belt and the move to cropping dominated systems. What techniques and approaches would be best to implement a cropping based system? And that's got lots of thumbs up. So I think people are interested in your ideas on that one.
I'm just not going to wade into that. I'm no cropping specialist.
Okay.
I think
That's a challenge for us.
I think, yeah, well, I think also, I know I can understand the economics driving that, but really, landscape systems are originally co-evolved to have animals in the system. Maybe not so much in Australia. I guess there are no ruminants here, but certainly the European or Northern Hemisphere crops that we grow are adapted to that. And so I'd sort of, if possible, caution getting rid of all livestock because they do play a role in soil health and the rest of it.
And I think there's a couple of questions in that and comments. Paul Galloway is saying, I don't think regen equals zero inputs, and mass balance replacement program is still possible. So that goes to Amir's point.
Yes, and that point a bit. Yeah.
The type of fertilizer is important. So slower release K sulfate rather than chloride, for example. And I think that goes to Glenn. I presume it's Glenn Reithmuller, who's an ag engineer out at Meriden, saying how do we economically get P&K back after selling the meat and the grain? So I think that's that circular issue. And if Simon's got any comments he'd like to make on this, no, welcome those. But
just one comment on that. I think that's where once you get for appropriate grazing and cropping, you get deeper soils and deeper root penetration. You are going to access a few more nutrients through that process, but probably not going to solve that long-term drain on those critical nutrients.
And then one more question then from the Karratha office. So a long way away and quite a different farming system to what we have here. How does regenerative farming improve biodiversity, especially native diversity and native plants being reintroduced, or is the focus only on pasture for feed? And it's certainly a big issue and a big push to think about the native seeds and shrubs across our landscape, both rangelands and in ag regions.
Look, I can just give you an example at home because that's a broad question that would have different answers for every environment. When I started farming, the land would get bare, and my father said the set stocking approach. He said since the late 20s, when he bought the farm, every 7 or 8 years we're wiped out by wingless grasshoppers. When starting in the late 80s, not only did we start putting a lot of our biodiverse tree breaks in, but when in the 90s we then swung over to regenerative grazing and kept the ground cover, wingless grasshoppers lost the bare ground for their egg beds. You go out in the dewy morning, you'd see millions of spiders on plants and insects and insectivorous birds starting to come out of the tree breaks. We haven't had a wingless grasshopper attack since the late 80s. And I couldn't, it was an instant wipe out almost into a drought when they came. So that's sort of a classic example for us of getting functionality back with a direct economic impact. And that's just one example I can quote. I can't speak for a lot of areas.
Thank you. That's a good suggestion. And then Carolyn Peake, who's at our Meriden office, is one of our research scientists, and she's got the farming systems trial, the long-term regenerative trial that we've developed. And that's one of the things that is being examined there. How do you have a system without livestock? So that's a kind of a, so because it's a research trial, you can have an extreme example. And I think that's part of the things that can happen on research stations. You can push the edges of things and then work out, come back to what farmers can.
Look, I think it's a really good question. I'm not qualified to answer it. I know there's some systems coming out of South America and otherwise that where you can't run the sort of ruminants, etc. That obviously there's whatever you want to call it, regenerative function that occurs. But yeah, I'm not qualified to that one.
Thank you. I think, as I said, there's some research questions. We have an opportunity to look at with our West Australian Research collaboration with our university partners and CSIRO, Rural Group Alliance, to look at in the climate space, but also in grains, Aboriginal agriculture, some new research ideas where we work as a team WA. And I think this is further grist for the mill for those sort of ideal for the sort of topics or the things that we've perhaps don't have the answers to. And that's something we should be excited about. If we had all the answers, there'd be no need for for us to all be sitting here and we'd be doing other less interesting jobs. I think I might bring it to a pause there. Want to thank you, Charles,
Pleasure.
for your generosity in coming and answering our many questions.
Very hard taskmaster, though.
I'll blame Simon for that and Jane. I know that you're speaking at the WA Museum tonight, so I look forward to listening to you then. And if everyone can online and again in the room, give our appreciation to Charles and to Simon. Thanks.